Hello everyone. Let us now discuss LeetCode question number 2559, count vowel strings in ranges. So here we are given with queries and words where these words contains strings, like this will be one string and like this will be another string. So these are the strings given in words. As you see here, these are the strings given. Now what are the queries given here? So the queries contains two things, the left one and the right one. So here L and R, L comma R, the same for every query, L comma R. So we need to specify that. So here we have L and here we have R. Now what we need to do is we need to check whether the word at index L and the words from index L to index R inclusively. From index L to index R, we need to return how many words are starting and ending with a vowel. So this is what we need to return. So we need to return, this is the input. This is the input which are given. Now the output is the output is 1 minute. The output is answer. We need to return answer of same size, specifying the number of words which start with a vowel and end with a vowel in the range LR inclusively. That means the index L and index R are also included. So this is the answer which we need to return. So I think you are clear with the question. Now let me take this example, like words is this one, and so now this is the words given and these are the queries given to us. What we need to do is we need to check what are the number of words which come under these queries. So what are the words under this queries, these words? So let me write one thing here. Let me check here. Is it starting with a vowel? Yes, it is starting with a vowel. And is it ending with a vowel? Yes, it is ending with a vowel. So mark it. So here it is not starting with a vowel. So don't consider it. Don't consider it. Here it is starting with a vowel and here it is ending with a vowel. So consider this one. Here too it is A and here it is A. A is a vowel. So consider this. Now there is only one character here. So this is also true. Now let me write the answer here. So let me write the answer which I need to return. So here I need to take the answer. I need to return the answer where it is of size of queries. 1 minute. It is the size of queries. Now the answer will be at the size of queries. That means just 3. So this is the space required. We will be specifying this answer. Now what we need to do is, here you have 0 to 2. That means take this index 0. Let me write the indices like 0, 1, 2, 3, 4. These are the indices. Now 0 to 2. It is included, it is not included, this is included. So the number of uh, words which are starting and ending with vowels is 2. Now let me come to 1 comma 4, 1 to 4. So there are 2, 3, 4. That means there is a count of 3 which is starting with a vowel and ending with a vowel. So 3 here. And 1 comma 1, there is only 1. So here it is not included. So will be initializing 0. Yes, we got the correct 230. So let me give you an intuition here. So here you have 0 as the index, 1 as the index, 2 as the index, 3 as the index, 4 as index. Here you have 1, just 1. What I am gonna tell you is you have till here it is 1. I am not talking about the index. Don't be confused here. Don't be confused here. Till here only 1. Let me take till here. So till here it is only 1. Till here it is 2. Till here it is 3. And till here it is 4. But what should I take? What if I asked for 0, 1, 2, 3, 4? If I asked for 2, 2, 3, what if I asked for that? So if I had a count that up to here, like up to here, you have the number of the count. If you have the count of the number of possibilities, like starting with a vowel and ending with a vowel, if you have the count, and here too, at here, if you have the count from here to here, if you have the count from here to here, that means you are having the total count from the beginning. From the beginning, you have the total count from the beginning, but you need the only this count from this index, to this index. Let me write it over here. You have the total count. One minute. You have this total count here. Now you just need this part. You just need this part. But how do you get it? So simply if you delete this count from the total count, if you delete this count up to here, there may be 1. Like so, let me give you this same example. I asked you for this. How many are the possibilities? How many are the solutions? So here it is 3. Let me take the total count and remove this count. So this count, till here you have only 1. Till here you have only 1. But from here to here you have 1, 2, 3, 4. Till here at this you have only 1. But from starting to end you have 1, 2, 3, 4. So you have 4. So if I remove this 1 from this 4, you will get 3 as the answer. So this is the correct one. 3, 1, 2, 3. So the intuition is you need to have the count at every index. So I will write the intuition. So the intuition is to have the count. To have the count. To have the count. Sorry. Count at every index. But what is the problem here is here you have 1, but at this index you have 1, like it is the index 0, but I'll be storing this in the next index, because at this index I cannot store here. I cannot store here the count, because if I store that here, I need to I'll be getting an out of bounds error. I will be storing it here, I will be storing it here, I'll be storing it here. But I cannot include this one. I cannot include the correct uh, the the same index value, same index possibility. So I'll be taking a prefix sum. So that is the intuition. To have the count at every index, the number of previous possibilities answers or answers. Maybe you can take any word you need. Previous, sorry, previous possibilities or answers. So we need to have the count at every index, the number of previous possibilities or answers. So what I did here is I have counted the previous possibilities or answers at every index. So I named the vector as a prefix sum. As we are doing the prefix sum, now we'll be iterating, we'll be iterating this, we'll be iterating the words. But before that, as I said, I will be having I will be storing the count in the next index. So this size, the size of this will be words size plus 1. So as I said, I will be storing in the next index. So words size plus 1. This is the size of prefix sum. Now, so here it is the code. Initially the pre, that means the initially I am considering there are no words which are starting and ending with a vowel. So pre is 0. That means the previously it is 0. Now n is the word size. As I said, prefix sum is of n plus 1. So this is the size of words. Now n plus 1, and I is equal to 0, I is less than n, I is greater than I plus plus. So I will be running a loop. I will be calculating the prefix sum at every index as I said in the intuition. Let me write the algorithm here. So I am writing the algorithm. Initialize pre as 0, n is equal to words dot size, and initialize our prefix sum array, pre-sum array with size n plus 1. Now after initializing it, we will be running a loop. Run a for loop from I is equal to 0 to n. Now what I am doing here is current size is the size of words. Now I am checking whether words of I0, the starting is an vowel, whether the starting is an vowel and the ending is also an vowel. Then I'll be incrementing our tree. That means the previous till the count. That means I am storing the previous count in pre. Now, as I said, I will be storing that in the next index. I am storing that in the next index. So pre sum I plus 1 is equal to pre. So this will help in determining the answer. So after that, algorithm run a loop from I is equal to 1 to n. Now after that, so if the word is starting and ending with a vowel, then increment pre and and make pre sum of I plus 1. is equal to pre. Now after that, after iterating this loop, so 1 minute, after iterating this loop, what we need to do is we'll be going through queries, and L is queries of I0 as they specified here, LIRI, and we'll be considering the answer of I. So what we need to do is initialize answer with size of queries. Now iterate these queries, and L is queries of I0 and right is queries of I1. And now L is the left and right is the rightmost one. So what we need to do is we will need, as I said here, we'll be calculating the prefix sum and storing in the pre-sum array. Now we need to remove from the right to the left. So right to the left. Now answer of I will be pre-sum of L plus 1 minus pre-sum of R. So as I stored in the next index, at this index it will be storing. So at this index it will be storing the count till this index. It will be storing in the next index. So it will be storing it here. Now this index will be stored here. So we are asked this as the right and this as the left. So I am considering the right plus 1 plus 1. So I'll be getting to this index. So it will be storing till here. So till here it will be storing, and here it will be storing till here. Right plus 1, pre-sum of right plus 1 minus pre-sum of L. So this is how you store and calculate the answer after iterating this loop, return the answer. So this is as simple as that. Yeah, I think you got the intuition, the algorithm, and let me give you the code. So this is the code that I am showing you from the beginning. Pre is 0, n is words dot size, a I o u, comparing these vowels, is the start is any vowel, and the end is any vowel. So increment the pre, that means the previous count. Now pre-sum of I plus 1 is current previous count. So we'll be iterating these queries, initializing the answer. So after that, return the answer. If you have any queries, please comment in the comment section. If you like this video, then share to your friends and subscribe to my channel. Thank you.